We like to think of human life as priceless, but if you break us down to our base physical reality, a 70-kilogram adult is really just a walking sack of common chemical elements. This chart shows the exact elemental recipe of a standard human. Specifically, we are looking at about 46 kilograms of oxygen, 13 kilos of carbon, 7 kilos of hydrogen, and a handful of nitrogen, calcium, and trace minerals. If you wanted to build a human from scratch and had to buy all of these raw ingredients yourself, what would be the most cost-effective supply chain? It turns out the final receipt for those materials fluctuates wildly. You might pay a meager $133, or you could end up with a bill well over $1 trillion. That massive price discrepancy exists entirely because the final cost depends on which scientific discipline you hire to source the ingredients. Let's start with the chemist's approach. In his book, The Body, A Guide for Occupants, author Bill Bryson ran the numbers on sourcing our exact elemental makeup. If you purchase the most chemically pure forms of each element from a scientific supply company, the premium is high. A standard human body will cost you roughly $150,000. But paying a premium for pure lab-grade elements is unnecessary when a DIY hack can get the job done for $133. Take oxygen and hydrogen. You can extract all you need from a few dozen gallons of tap water, which is practically free, using a basic electrolysis setup. The carbon requirement is just as easy to meet. You can source that by spending about $75 on bags of high-quality charcoal at the hardware store. This receipt tallies up the rest of the hacker's method. You extract your nitrogen and sulfur from $31 of standard agricultural fertilizer, set aside $20 for the remaining trace elements, and you hit that grand total of $133. The problem with reducing a human to cheap raw powders and gases is that it ignores the complex physical reality of biology. Humans aren't made of isolated individual elements bouncing around in a sack. We are constructed from highly complex organic molecules, like specialized proteins and carbohydrates. If you pay a laboratory to synthesize those complex molecules from scratch, using your charcoal and tap water, the labor and processing fees would be astronomically high. The biologist has a much more practical workaround. Head to a livestock auction, buy a whole pig for about $267, and grind it down into a soup of parts. From a strict molecular standpoint, a pig provides the exact same pre-assembled chemical building blocks required to put together a human being. Borrowing pre-assembled biology from another mammal serves as an incredibly efficient, cost-saving shortcut compared to synthesizing life from raw carbon. Finally, there is the physicist's approach. If you want to bypass existing matter entirely, you can apply the principles of mass-energy equivalence, E equals mc squared, and conjure atoms directly out of pure energy. To execute this, you have to use a massive particle accelerator, like the machinery at CERN, smashing particles together to convert energy into mass. This chart shows the staggering scale of that energy requirement. Generating 70 kilos of matter from scratch requires 10 to the 17th joules, 70 times the energy consumed by the entire planet in a year. Factoring in the cost to monopolize the Earth's power grid pushes this method's financial reality into incalculable territory. Physics proves that trying to create mass out of absolutely nothing is the most inefficient and expensive supply chain in the universe. This comparison matrix lays out our supply chain thought experiment side by side. We have the $133 hacker discount, the $267 biological shortcut, and the infinite physicist's bill. Looking closely at these numbers reveals a stark truth about our existence. The actual physical matter that makes up your body has almost no financial value. Your worth isn't found in a pile of raw charcoal or tap water. It exists in the millions of years of evolutionary engineering and the highly intricate molecular bonds required to assemble those common elements. You are not valuable because of what you are made of. You are valuable because of how you are made.